A very pleasant morning to one and all. Welcome to Vidhyalakshmi YouTube channel. Myself Shakila, ME B.Ed, Department of Physics. Today we discuss about Class 11 Physics, Chapter 1 Numerical Problems. Yes, so first problem, if a submarine equipped with sonar, the time delay between the generation of a pulse and its echo after reflections from an enemy submarine is observed to be 80 seconds. If the speed of sound in water is 1460 ms per minus 1, what is the distance of enemy submarine? So this is the first question. So first you have to understand what you have to find in this problem is you have to find the distance between the two submarines. Okay. So one thing, this is one submarine and this is one submarine. Okay. So one submarine is having with equipped sonar. So sonar is like sending the signals. Okay. So it transmit and receive the signals. So the one submarine have equipped with sonar, it send the signal to another submarine and it receives the signals. So the distance between the two submarines we have to find. So this is your questions. So what are the given values in this problem is the speed of sound in water is 1460 and the time taken by the pulse for to and fro. So the first submarine has some sonar. So it will be send the signals and receive the signals. So the time between the two submarines is having 80 seconds. So and next thing, so the t is equal to t by 2. Why we have to using t by 2? By divided by 2 means, so the distance between the two submarines is 80 seconds. So the signals send and receive the signals, we have to divide by 2. So t is equal to t by 2, 80 by 2 is the 40 seconds. So already we know the formula for speed of sound. So speed of sound is nothing but distance by time taken. So we have to find the distance only, no? So distance only we have to use the divided by 2 is coming on to this side, cross multiply. So v into t. So already before we have to substitute small t is equal to capital T by 2. So what is the value of capital T by 2 is nothing but 40 seconds. So small t is equal to the speed of sound value is 1460 and the t by 2 is 40. So how to find the distance between the two submarines? 58,400 meter. So we have to convert the kilometer into 10 power 3. So 58.40 kilometer. Okay. So this is the distance between the two submarines. And next problem. And second one is a simple problem. The radius of the circle is 3.12 meter. Calculate the area of the circle with record two significant figures. So very simple problem. You know the formula for area of the circle. Area A is equal to pi r square. So what are the given values in this problem? Radius of the circle, that is r is equal to 3.12 meter and formula for area of the circle is A. So A is equal to pi r square. So what is the pi value? 3.14 and r square is 3.12 into 3.12. We have to multiply this 3 value. We get the answer for 30.566016. So in these conditions, according to the rule of significant figure, we have to consider A is equal to 30.6 meter square. So we have to multiply two methods. So directly you have to multiply this 3 value and also one more method we have to use logarithmic method. So logarithmic method we can calculate it very easy to solve this problem. So this is the second problem and next third problem. So what is the third problem? Assuming that the frequency gamma of a vibrating string may depend upon first one applied force and second one length and third one mass per unit length. So prove that gamma is directly proportional to 1 by L root of F by M using dimensional analysis. Okay, already we have to discuss in this first chapter dimensional analysis and you know the formulas very well. Force, mass, length and frequency, every dimensional formula you know very well. So using this formula we can solve this problem. Okay, so first thing, the frequency is directly proportional to first one is applied force. So that is gamma Yes. So, the gamma is directly proportional to force, and one more thing, length, and third one, mass per unit length. You have to remember this three one. The frequency is directly proportional to force, length and mass. Okay. And next thing, we have to remove the directly proportional. We have to apply the dimensional constant, that is k. So, gamma is equal to k, L power A, F power P and M power C. So, we have to apply the homogeneity dimensions rules. We have to apply the powers. So, L power A, F power P and M power C. And next step, you have to apply one by one. What is the dimensional formula of force and dimensional formula for length and mass? So, first thing, formula for force. So, what is the formula for force? F is equal to ma. F is equal to ma. So, the dimensional formula for m is m, and acceleration. So, what is acceleration? Velocity by time taken. So, velocity we have to write displacement divided by time taken. So, how to write the displacement in dimensional? We can write that L, and time we can write that T. So, what is the final formula for dimensional formula for velocity? L T power minus 1. We have to apply the velocity formula in this case, L T power minus 1 and divided by T. So, it is coming on to upside, L T power minus 1, T power minus 1. So, what is the final formula for acceleration? L T power minus 2. Okay. Is it clear, all of you? So, F is equal to ma, and what is the dimensional formula? M is, mass is m, and acceleration is L T power minus 2. So, we have to apply dimensional formula for force is equal to m L T power minus 2. And next thing, dimensional formula for density. You know the formula for density, mass per length. So, m we have to consider mass per length. So, mass dimensional formula is m and length dimensional formula for L. So, we have to write that m power 1 and L power minus 1. So, this is the second one, the dimensional formula for density. And third one, we have to compare this all the formulas using this equation, that is gamma is equal to k L power A, F power P and M power C. So, what is gamma? That is nothing but frequency. So, how to write the formula for frequency? F is equal to 1 by T. F is equal to 1 by T. So, we have to write that F is equal to dimensional formula T power minus 1. So, we have to apply in this case frequency M power 0, L power 0, T power minus 1. So, only the frequency having a T power minus 1. So, T power minus 1. And next thing, force formula. So, gamma is directly proportional to k, L power A, F power B and M power C. So, this is the frequency dimensional formula, and this is a mass dimensional formula, and this is a length dimensional formula, and this is a force dimensional formula. Is it clear, all of you? And next thing, we have to combine these equations. So, how to combine this equation means L power A and M power B. So, you have to multiply 1 into B, 1 into B, L power B, and T power minus 2. So, minus 2 into B, minus 2B. And next thing, M power L power minus 1 into C. So, L power minus 1 into C minus C. So, this is the dimensional formula for gamma is equal to k L power A, F power B and M power C. So, is it clear, ma? And next, third step. So, we have to compare left hand side and right hand side. So, what is the left hand side M power value? That is 0. And what is the right hand side M power value? That is B plus C. So, this is the first equation. So, this is the first equation. So, B plus C is equal to 0. And second thing, we have to compare the L power value. So, left hand side L power value and right hand side L power value, that is left hand side that is 0 and right hand side A plus B plus minus C is equal to 0. This is the second equation. And what is the third one? We have to compare the T power value. So, left hand side T power value is minus 1 and right hand side T power value is minus 2B. So, minus 2B is equal to minus 1. So using these three equations, we have to find the A value, B value and C value. So how to find this B value means minus 1 plus 1 by 2. So we get the B value, and using this B value, we have to substitute the equation 1 or 2. We have to use anything. So first equation, so B plus C is equal to 0. So B plus C is equal to 0 means C is equal to minus B. So what is B value? 1 by 2. Minus B means minus 1 by 2. So B value is plus 1 by 2 and C value is minus 1 by 2. So we get the two values B and C, and directly substitute this equation, that is A plus B plus minus C is equal to 0. So A value, A plus, what is B value? Plus 1 by 2, and what is C value? Minus 1 by 2. So we have to directly substitute this value, we get the A value is minus 1. Is it clear, ma? So A value and B value and C value we get means directly we have to apply the powers of frequencies directly proportional to L power A, F power P and M power C. So substituting this value A, B, C, we get the value of gamma is equal to K, L values, that is A values minus 1. So L power minus 1. And F power B, what is B value? Plus 1 by 2. And what is C value? Minus 1 by 2. So M power minus 1 by 2. So already you know very well, L power minus 1, we write that 1 by L. So that is 1 by L. And what is the 1 by 2 value? So that is root. So F power plus 1 by 2, we can write that root F, and M power minus 1 by 2. What is the minus 1 by 2? Minus 1 by 2, that is M power minus 1 by 2 means that is root value, root M. So we can write that divided by M. So finally we get the answer for gamma is equal to 1 by L root of F by M. So using dimensional formula, we get the answer for this problem. And next one, fourth problem. So what is the question? Jupiter is at a distance of 824.7 million kilometer from the Earth. Its angular diameter is measured to be 35.72 seconds. Calculate the diameter of Jupiter. So what are the given values in this problem? So distance of Jupiter from Earth, distance of Jupiter from the Earth, that is D is equal to 824.7 into 10 power 6 kilometer. So kilometer you have to convert meter into 10 power 3, and what is the answer for meter? D is equal to 824.7 into 10 power 9 meter. So this is the first given value. And next one is angular diameter, that is theta value is given. So 35.72 seconds. So already we have discussed in this first chapter, seconds we have to convert radian, that is 1 second is equal to 4.85 into 10 power minus 6 radians. So this is the value, constant value for convert seconds to radian. So 35.72 seconds is converted into radian into 4.85 into 10 power minus 6. So you have to multiply this value, we get the answer for angular diameter theta. So what is the question in your problem? You have to calculate the diameter of Jupiter. So diameter of the Jupiter, how to calculate the diameter of the Jupiter means using parallax method. Already one important 3 marks questions in your first chapter, parallax method. So how to find the parallax method means that is a theta is equal to h by x. You remember all of you, theta is equal to h by x. How to find this theta is equal to h by x means we have to using the tan theta, opposite by adjacent. So using this type of formulas we apply in this problem, we get the answer for diameter of the Jupiter. So in simple example, so you have to consider this is an Earth and this is a Jupiter planet. Okay, and what is the angle of this Earth to Jupiter? That is 35.72 seconds. Is it correct? And next, what is the distance of this Jupiter from the Earth? That is 824.7 into 10 power 9. So what is your question? you have to find the diameter of the Jupiter. Is it correct? You have to find the diameter of the Jupiter. So how to using the parallax method means, so theta is equal to h by x. Okay. So this is a theta value and this is the distance h and this is x. You have to consider using parallax method. Okay. So the diameter of the Jupiter d we have to find. So theta is equal to small d by capital D. Okay. So this is a small d and this is capital D. So d we have to find means divided by d is coming on to this side. So theta is equal to small d by capital D. So small d is equal to, so divided by d is coming on to this side, multiply theta into d. So already you know that what is the theta value, that is 35.72 into 4.85 into 10 power minus 6 radians. Okay. So in your given values seconds, we have to convert radian, multiply 4.85 into 10 power minus 6. So 824.7 into 10 power 9, and what is the theta value? 35.72 into 4.85 into 10 power minus 6. So you have to simplify this equation. You get the answer for diameter of the Jupiter d is equal to 1.428 into 10 power 5 kilometer. So this is a 10 power 5 kilometer. Okay. And next, fifth problem. So in last problem in this chapter, the measurement value of length of a simple pendulum is 20 centimeter known with the 2 millimeter accuracy, and the time for 50 oscillation was measured to be 40 seconds within 1 second resolution. Calculate the percentage accuracy in the determination of acceleration due to gravity g from the above measurement. Okay. So in this problem, what is the question? What you have to find means, you have to find the percentage accuracy. So percentage accuracy for acceleration due to gravity. So g ku vandu percentage error vandu we have to find. Okay. So you know the formula, T is equal to 2 pi root of L by G. So this is the formula. You have to find the time period of the simple pendulum using this type of formula. T is equal to 2 pi root of L by G. So in this problem, you have to find the acceleration due to gravity, that is G value you have to find. So using G value, some rearrangement in this equation. So how to change this equation means, we have to taking square on both sides. So T square, so 2 pi taking root square means 4 pi square, the root it will be cancelled, and L by G. Okay. So what is the question? G we have to find. So G we have to find. So G is equal to, so this side we have to coming, G is equal to 4 pi square and L by T square. And next thing, we have to using one formula, that is relative error formula. So what is relative error formula? Relative error, that is absolute error divided by true value. So that is delta G divided by G. So this is the absolute gravity value and divided by true value. Okay, delta G by G is equal to, so already know that error is always using only additions only. So delta L by L and plus 2 delta T by D. Why we are using in this 2 means, in this problem the T value is doubled, so T square. So that's why we have to using the 2 into delta T by T. So this is the formula we have to using in this problem. And next step, directly we have to substitute this value and we get the answer. Okay. And next one, the length of the simple pendulum, that is L is equal to 20 centimeter, and accuracy, that is delta L is 2 millimeter. So you have to convert centimeter 0.2 into centimeter, that is 10 power minus 3 means 0.2 centimeter. And one more given value is, that is time for 50 oscillations. So T is equal to 40 seconds and resolution, that is delta T is equal to 1 second. So the 4 values are given and directly you have to substitute this formula, that is delta L by L plus 2 into delta T by T. You have to substitute this value and you get the percentage error for acceleration due to gravity. So that is delta G by G into 100. So 1.2 by 20 into 100, and you have to simplify this value. And substitute this value and we get the answer for 6%. So this is the percentage accuracy in acceleration due to gravity. So I hope all of you understand this numerical problem. Thank you so much.